So welcome everybody to this latest revision video on 162 Maths. In this video we'll be continuing with the series of AQA GCSE Maths 2022, looking at the higher paper 2 calculator paper and with a focus of the numbers section. Now there will be a link to the questions that are in this video that you can click on and download and have an attempt at before watching this video and going through the answers. So before we get started on some example questions, let's just have a look at the advanced notice of what's going to appear in the number section on the higher paper 2. Now looking at the first two ones, which is prime numbers and cube numbers. So again, with prime numbers, it's important you know your prime numbers between 1 and 100. With cube numbers, you need to know what 1 to 5 is and go up to 10. So the fact that you've got a calculator should make this question relatively quite easy. Reciprocals, again, recognizing that the reciprocal of x is going to be 1 over x, and try not to get confused with parallel perpendicular where it's minus 1 over, so just be mindful of that. With decimal places, that's all to do with rounding, and again that can appear in any topic, in any of the sections. With bounds, again you're looking at error intervals and you're looking at upper lower bounds, and you're also looking at max and minimum calculations. With fractions and products, well, product just means multiplying. So in some form, it's a case of multiplying fractions, and that's going to include working with proper, improper fractions and mixed numbers as well. And then with negative indices, it's again remembering that a minus power, so a negative power equals a reciprocal. And again, it's always worth mentioning in terms of fractions. So when you're doing the reciprocal of a fraction, just simply flip it. So again, many of these topics I reckon could be included in parts of other questions, but again, individually, they're most likely going to appear on the start of the paper, maybe as one of the multiple choice questions. So let's now go through some example questions that cover these topics. Now, just a little reminder, you can have an attempt at working at these questions by clicking on the link in the description below. So have a go at these questions before watching the video as we go through the answers. So looking at question 1, which involves prime numbers. So again, all it's asking for is to write down all the prime numbers between 40 and 50. So that's going to be 41, 43 and 47, in which you'd lose 1 mark for every one of those 3 numbers that you forgot to write. Moving on to question 2, it says A and B are both prime numbers. They are each less than 20. Give an example of where A plus B is odd but not prime. So here, in terms of the prime numbers that are less than 20, so we're looking at 2, 3, 5, 7, 11, 13, 17, and 19. So I want to give an example of where when I'm adding 2 numbers, it gives me an odd number, but it's not prime. So in order for me to add 2 numbers together, I've got to add an even number and an odd number together. So here I'm definitely going to have 2. So 2 plus 3 is 5, so that's prime. 2 plus 5 is 7, which is prime. 2 plus 7 is 9, and that's not prime, so then it's going to be 2 and 7 as one example. I could also have had 2 and 17. I could also have 2 and 11. So again, multiple possible answers I could have. That's going to be correct. Moving on to question 3, it says, I'm thinking of a prime number. Its digits add up to a square number. Write down all the prime numbers that I could be thinking of. So here, what we're looking at is prime numbers. So we're looking at 2. And again, I don't think it's going to be a single digit prime number. So looking at 11, that's going to be 2. That's not a square number. 13 is, so then it's going to be 13 as one possible answer. Looking at question 4, it says Zoe's password is made up from 4 different digits. She remembers it as 2-digit numbers. The first 2-digit numbers is a prime number between 10 and 20. The second is a prime number between 20 and 30. List all the possible outcomes. So in terms of the first one, we want to list all the prime numbers that are between 10 and 20. So we're looking at 11, we're looking at 13, we're looking at 17, and we're looking at 19. Now, in terms of all the prime numbers that are between 20 and 30, well, that's going to be 23 and 29 rather. So then from this, what we're going to do is develop our 4-digit numbers. So I've got 1123, 1129. Then I've got 1323, and then 1329, 1723, 1729, and finally 1923 and 1929. Moving on to question 5, it says write down all the cube numbers between 100 and 400. So looking at this, if I get my calculator, it's the most easiest thing for me to use, particularly as it's a calculator paper. So from this, all I've got to do then is do, well, I think the first 3-digit number is going to be 5 cubed, which gives me 125. Then 6 cubed is going to give me 216. And 7 cubed going to give me 343, and I think 8 cubed is what's going to take me over 400, but we'll just double check it does. So the answers then, it's going to be 125, 216 and 343. Moving on to question 6, it says circle the number that is 1 less than a cube number. So what I need to do is just add 1 to each of these numbers. So I've got 21, 23, 25 and 27. So which of these numbers in blue is a cube number? It's going to be the last one. So the answer is then going to be 26. Moving on to question 7, it says circle the value of 5 cubed, and 5 cubed is 5 times. And again, I could just simply type this into my calculator, but the correct answer is 125. Moving on to question 8, it says circle the cube number. Now again, if you're ever unsure about these questions, you can kind of be smart and just basically cube root each of these numbers. So looking at the calculator in terms of where the cube root is going to be, so here if I do the cube root of 9, and what I'm looking for is a whole number. So that doesn't work. So let's try 10,000, which doesn't work. So then let's try the next number, which is 333. Which doesn't work, and then the cube root, so it must be this last one, 729, and it gives me 9, so the last one is the correct answer. Moving on to question 9, it says show that there are exactly 5 3-digit cube numbers. So again, all I need to do is just kind of, I've already done some of them. So here we're looking at 5 cubed, 6 cubed, 7 cubed, 8 cubed, 9 cubed, and 10 cubed. So 5 cubed is 125, 6 cubed is 216, 7 cubed is 343, 8 cubed is 512, 9 cubed is 729, and 10 cubed is 1000. So here you can see that we've only got 5, so only 5 3-digit cube numbers. And again, what you might want to do is maybe do 4 cubed, which is 64, just to show that there's no cube numbers that are less than 125. So moving on to question 10, it says circle the reciprocal of 5 6. So again, whenever you've got doing the reciprocal of a fraction, you just basically want to flip it. So here the correct answer is going to be 6 over 5. And again, if you're ever unsure, you can always just use your calculator. Question 11, the reciprocal of 4. So that's going to be 1 over 4, which as a decimal is 0.25. So it's going to be our last option. Then with question 12, it says circle the value of the reciprocal of 0.2. So that's going to be 1 over 0.2. And again, if you're ever unsure, it's a calculator paper. So just do 1 divided by 0.2 equals, and that gives me 5. So it's going to be our last option. The next one, circle the value of 8.5 to the power of 0. Well, anything to the power of 0 is just 1. And then for question C, it says work out 27 to the power of a third. And again, give your answer as a fraction. So again, I can work this out now. Because it's worth 3 marks, I'm going to show a bit of working out. And just word them out separately. So this is going to be 3 times, and then it's going to be 1 over 49. So the answer then is going to be 3 over 49, which doesn't simplify. And so there is my final answer. Moving on to question 13, it says, what is 6.2819 to 2 decimal places? So it's going to be just 6.28. Moving on to question 14, it says the length of each side of a regular pentagon is 8.4 to 1 decimal place. Complete the error interval of the length of one side. So here, 1 decimal place represents 0.1 of a centimetre. So if I divide that by 2, I get 0.05. So then the limits are going to be 8.4 plus or minus 0.05. So then the lower limit is going to be 8.35. And the upper limit is going to be 8.45. Then says work out the error interval of the perimeter. So all I need to do there is just multiply both of these numbers by 5 because there are 5 sides to a pentagon. So 8.35 times 5 gives me an answer of 41.75, and 8.45 times 5 is 42.25. Then moving on to question 15, it says that a length of a pipe is 6 meters to the nearest meter. Complete the error interval for the length of the pipe. So it's the nearest meter, then I divide that by 2, which gives me 0.5. So I'm going to do 6 plus or minus 0.5, which gives me a lower limit of 5.5 and an upper limit of 6.5. Then working with question B, it says that the length of a different pipe is 4 meters to the nearest meter. Ollie says that the total length of the 2 pipes is 11 meters to the nearest meter. Give an example to show that he may be correct. So let's first of all have a look at this. So the limits or the bounds of the second pipe is going to be 3.5 to 4.5. So if I pick the biggest length of the first pipe, and that's going to be 6.49 recurring. Remember, we can't use 6.5 because obviously that's going to be rounded up then to 7 meters. So I've got to pick the next number up, plus the biggest pipe for the second one, which is going to be 4.49 recurring. And then if I then just simply word that out on my calculator, so I've got 6.4 and then go a little bit crazy with the 9s, plus 4.4 and then go a little bit crazy with the 9s on the 4.49 equals, and it gives me then 11. Now that is roughly going to be given as that. So again, I could have picked any example of that. So I would say, although that does give me 11 meters, you could pick another one. So let's go for 6.45 plus 4.40. And again, if I add those up, so 6.45 plus 4.4, it gives me an answer of 10.85, which rounds to 11 meters. So again, there's loads of different examples you could pick to satisfy Ollie's claim. Question 16 says this sign shows when a lift is safe to use. It says total mass of people must be 450 kilograms or less. Ben and some other people are in the lift. Their total mass is 525 kilograms to the nearest 5 kilograms. Ben gets out and he has a mass of 78 kilograms to the nearest kilogram. Is the lift now safe to use? So let's have a look at some of these. So we're not going to touch that the lift needs to have 450 or less. So here, what we're looking for is, in the worst case scenario, we're looking for the heaviest total weight, which in this case is going to be 527.5. And again, how I've got that is just 525 plus or minus 2.5. So for the upper, I'm going to add 2.5. So that's what I get. Now, the worst case scenario, I want the lightest Ben. And the lightest Ben could be to the nearest kilogram is going to be 77.5 kilograms. So here, if I then do 527.5, take away 77.5, and let me just type that into my calculator now. I get an answer of 450. So again, worst case scenario, that it's going to be safe. So yes, it will. Oh, not with 3 L's. It will be safe. So moving on to question 17, it says that a formula connecting speed distance time is speed equals distance over time. D is 160 to 2 significant figures. T is 7.2 to 2 sig fig. It says work out the upper and lower bounds of S. Give your answers to 3 significant figures. So here what we need to do is work out the lower bound. So the second sig fig represents a 10. So I'm going to do 160 plus or minus half of 10, which is 5. Then for here, there's T. The second sig fig is 0.1, so here I'm going to divide that by 2, which gives me 0.05, so it's going to be 7.2 plus or minus 0.05. Then working out what those bounds are going to be, well, this is therefore going to be 155 to 165, and this value here is going to be 7.15 to 7.25. Now to get the smallest fraction, so the smallest is going to be with D over T. This is going to be the slowest or the smallest, and this is going to be the biggest. So the smallest S is going to equal the smallest D, which is 155, divided by the biggest T, which is 7.25. And if I type that into my calculator, 155 divided by 7.25, it gives me an answer to 3 significant figures of 21.4. Now for the biggest S, then what I'm wanting is D to be the biggest and T to be the smallest. So the biggest that D can be is going to be 165, and the smallest T can be is going to be 7.15. And hopefully that gives me an answer that's bigger than 21.4. So 165 divided by 7.15, and that to 3 sig fig gives me 23.1. And so here the upper and lower bounds for S is going to be 23.1 and 21.4. Bit sneaky to put lower bound for upper bound first, so just be mindful of that. Moving on to question 18, it says work out the value of 32 to the power of minus 3/5. So again, I could easily type this into my calculator, but with it being worth 2 marks, I'm going to show a bit of working out. So here, what I've got is the minus makes it 1 over, so I've got 32 to the 3 over 5, and that then becomes 1 over the 5th root of 32 cubed. Now the 5th root of 32 is 2, so it's 1 over 2 cubed, which is 1 over 8, and that there is my final answer. Now if I wanted to give it as a decimal, that should be fine. It's only because 1/8 is a terminating decimal, so that gives me 0.125. So any of those 2 answers would be fine. Moving on to question 19, so it says work out the value. So again, we're looking at indices. So here, working them individually, when we're dividing and the bases are the same, we take away the powers, so that's going to be 3 to the power of 7, and then divided by, and this one here, even though this one hasn't got a power, it's got a power of 1, so that's going to be 3 cubed, leaving with an answer of 3 to the power of 4, or I can write it as 81. Moving on to question 20, it says work out the value of 81 to the power of minus 1/4. So that's going to be 1 over the quart root of 81, which is 1 over 3. The next one then says write 16 times 8 to the power of 2x as a power of 2 in terms of x. Well, for this, what I need to do is rewrite each of these base numbers as a power of 2. So 16 is 2 to the power of 4, and 8 is 2 to the power of 3, and then I've got 2x. Then from this, I've got 2 to the power of 4. When I've got brackets, I multiply the powers. So that's going to be 2 to the power of 6x. And then when I'm multiplying, I add the powers. So it's going to be 2 to the power of 4 plus 6x. And there is my final answer. Moving on to question 21, it says work out the cube root of 8 times 5 to the power of minus 2. So let me just rewrite this question so it's a little bit easy to see, just in case it's a little bit fuzzy. So the cube root of 8 is 2 times 1 over 25. So that's then going to be 2 over 25. And then we want to write that as a decimal. So 2 divided by 25, and that gives me 0.08. And I'm just get rid of that because that can't be my final answer. Then moving on to question 22, it says circle the value of 3 to the power of minus 2. Well, that's just going to be 1 over 3 squared, which is 1 over 9. So that's going to be our third option. Then says work out the value of this. So anything to the power of 0 is 1 plus, and then 8 to the power of, so it's going to be 1 over 8 to the power of 2/3, which is 1 plus 1 over the cube root of 8 squared, which is 1 over, let me just correct that. So this is going to be 2 squared, which is 4. So it's going to be 1 plus a quarter. So that's going to be 1.25, or I could write it as this, or I could write it as 5 over 4. So any of those three answers would be fine. Moving on to question 23, it says work out the value of 8 and minus 2/3. So again, very similar to what we've already done before. So this is going to be 1 over the cube root of 8 squared. So dealing with this first, that's going to be 2. So it's 1 over 2 squared, which is 1 over 4. Or you can write it as a decimal. And then moving on to our last question, it says express 1 over the cube root of x squared in the form of x to the power of a. So here it's just a case of working backwards. So here I've got x. Now because I've got 1 over, I've got negative power. And then the numerator is the power, which is 2. And the denominator is going to be the root, which is 3. So here a equals minus 2/3, or the final answer is going to be x to the power of minus 2/3.